Okay, so we're going to be doing classwork 11, multiply monomials. You cannot do this on Desmos, so you're going to have to listen, follow along, hear the logic behind how these things work so that you can do them on your own. Well, talking about logic, we're going to be using 4 rules to cover this. Now, the ones that are going to be covered in this worksheet is only going to be the product rule and the power rule. Let's get started with the product rule, okay? The product rule states that as long as I have you see the numbers in green, the x, as long as they have the same base, right? It doesn't matter what exponent they have. So for example, let's just imagine that 2 is my base. Okay? These are my bases. Now, if the exponent is 5 here and is 6, that doesn't really matter. Okay? The only thing that I need to be careful about is that these are the same, right? And that this is multiplying, okay? It has to be multiplying. Now, it's possible that this is in parentheses, right? But they're still multiplying each other, so that still counts, okay? If they are next to each other and they have the same base, then this is what you do with them. You will add the exponents, okay? You will add the exponents, and the result of adding those exponents will be 2 to the 11. Now, how does this work? I'm going to go ahead and zoom in here. And if I were to spread this out, uh, 2 to the 5, what is 2 to the 5? 2 to the 5 is really a repetition, okay? So if I have 2 to the 5, 2 to the 5 is the same as 5 2's. Okay, I have 5 2's multiplying each other. That's what 2 to the 5 means, okay? That's what 2 to the 5 means. Now, if you see this multiplying thing here in the middle, right? Well, that's what's between 2 to the 5 and 2 to the 6. Right? 2 to the 6 is the same thing as 2 to the 5, except I have 6 2's multiplying each other. Okay? That's what 2 to the 6 means. So can you see how we just end up adding them? Right? How many 2's do we have down here altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the same as 5 plus 6, giving me 2 to the 11. And that is how the product rule works. Now let's actually apply this to our problem. Okay. So we're looking at a problem right here, and we have a to the second times a to the third times a to the sixth. Okay. Really, what is a to the second plus 3 plus 6? Well, 2 plus 3 is 5, plus 6 is 11, and that would be my answer. Not bad, right? So that's how you would do problem number 2 and problem number 3. The only exception with problem number 3 is that you're not going to be adding 4 plus 3. You're going to be multiplying 4 times 3. Okay? So 4 times 3 gives me 12. Okay? And then here I have for my x's, right? What is, wait a minute, I don't see anything here. Oh, it's x to the 1. So if you don't see anything, it's x to the 1. So this is x to the 1 plus 3, okay? Now, you can do this in your head and just write 4, okay? And then you have your y's, right? My y's are right next to each other. What is y to the 3 plus 5. You can do it in your head, and it would be y to the 8. And that's how would you do that. Okay, so this is how you do those problems with just product rule. But what about problems that have another rule in place, right? What if I have an exponent on the outside? Well, we're going to have to talk about the power rule, okay? So let me just scroll over here. The power rule. So the power rule states that if I have x to the n, right, which that can be any number, right, raised, again, as you see in these parentheses, right, raised to the b, which that is also any number, right, then you actually multiply these exponents, okay? So if I had 2 to the 2 to the third, right, and then I raise this again to the fourth, right, then it would be 2 to the third times 4. And that would be 2 to the 12th. Okay. Now, how does this work? Well, what is 2 to the third? Well, as we have mentioned earlier, right? Just as we had did this, 2 to the third is just simply three twos, right? Multiplying each other, right? But this 4 says, hey, I need 4 groups of this, okay? So that means I need 4 of these, which I'm going to repeat those. 2 times 2 times 2, that's the number, that's 2 of them. 2 times 2 times 2, that's 3. And 2 times 2 times 2, that's 4. So now I have, right? I'm gonna color code this. I have 1, 2, 3, 4 of them. Okay. Now, if I add these all together, right? If I counted them, I have 1, 2, 3. I'm not gonna cross them out. Excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's how I ended up with 2 to the 12th, which you can get, right? You can get that by simply multiplying 3 times 4. Okay. So let's go ahead and actually apply this to our problem. So let's zoom out. And we're going to be doing problem number 5. Okay. Now, if I have more than one variable, and our example, we only had 2, right? Right? We only had one letter in here or one number. But if I have more than one, like in this case, I have a 3, I have a p, and I have an r squared. If I have more than one, then I'm really just going to distribute this 2, right, to everything inside. Okay. And if these don't have an exponent, like the 3 doesn't have an exponent, the 3 has an invisible 1 as an exponent, and the p has an invisible 1 exponent as well. So in this case, right, I have, what I'm going to do is my first problem is I'm going to distribute this 2 to, to 3. So that's going to look like this. Okay. 3 to the 1 times 2. What's 1 times 2? That is 2, right? So that's going to be 3 to the 2. All right. Now the same for the p, right? I'm going to distribute this 2 to the p. So what is p to the 1 times 2? Well, that is p to the second, right? And then I'm going to do the last one, right? The last one is the r. So what is r to the 2 times 2. 2 times 2 is 4, so this is r to the 4. And that is how you solve problems, or not solve, that's how you really put these exponents together.